Let's get right into one of the biggest challenges in AI right now. How do you actually connect a large language model to the real world? How do you give it access to your company's data, your services, and let it actually do things for you? Well, today we're going to explore the blueprints for building that exact bridge. It's a really strange situation, isn't it? We've got these incredible AIs that can compose music, they can write poetry, they can debug code, but then you ask a simple question like, hey, where's my order? And it just draws a blank. And that's because all of its incredible knowledge is totally disconnected from real-time personal data. It knows all about the idea of a flight, but it knows absolutely nothing about your flight.
So, to get an AI to actually act on your behalf, it needs that connection. It needs a bridge to all the live systems that run our world. And, just like a real bridge, there isn't just one single design. Today, we're going to walk through the architectural blueprints that developers are using to build these absolutely critical connections.
So, as we start thinking about building this, we immediately face a really fundamental choice. And it all comes down to two main philosophies, which are basically about one thing. Who's in charge here?
Think about it like this. Are you hiring an assistant that you need to micromanage, feeding them every single piece of information step by step? Or are you hiring a manager where you can just give them a high-level goal, a set of tools, and then trust them to figure out the rest? This one distinction, it defines everything that comes next. So first up, we've got the assistant model. We call this direct integration. In this setup, your application is completely in control. It is the boss. It decides which APIs to call, it goes and gathers all the necessary data, and only then does it hand that neatly packaged info over to the LLM with a super specific instruction.
The flow here is totally linear, completely predictable. The user asks a question, your app goes and fetches the exact data it needs, then it bundles all of that up into a prompt for the LLM. The AI's job here is very, very specific. Just turn this data into a helpful, human-friendly sentence. That's it.
So for that flight status example, your app would call the airline's API. It gets back all this raw, kind of messy data. Computer code that might look like status, delayed, gate B52, new departure 2030. It then hands that to the LLM and just says, hey, turn this into a helpful response. It's straightforward, it's really reliable, and it's pretty cost-effective. Okay, now for the second philosophy, the manager model. This is known as the Agentic framework. And here, we completely flip the script. The LLM is the one in charge of the whole process. You don't give it data. You give it a toolbox filled with your APIs, and you give it a goal. It's up to the AI to then reason about which tools it needs to use to achieve that goal.
So here, the flow is way more dynamic. It's actually a loop. The user asks a question, but instead of our app fetching data, the LLM starts to reason on its own. It might think, to answer this, I'm going to need the flight status tool. Your backend then runs that request, sends the result back to the LLM, which then decides if it's done or if it needs to use another tool.
This is where the agentic pattern is so powerful. For a complex task like, say, booking a dinner reservation, the LLM can chain these actions together. It can decide to first search for Italian restaurants, then check for availability at 8 p.m., and then finally use a booking tool to lock it in. All from one single, high-level request from you.
So what it all comes down to is a trade-off. Direct integration gives you full control. It's cheaper, it's easier to build, but it can get kind of clunky when you start adding lots and lots of APIs. The Agentic framework, on the other hand, is way more flexible and powerful, but it's definitely harder to debug, and you've got to put safeguards in place to prevent the AI from making mistakes or hallucinating an API call that doesn't exist. But look, those two core philosophies, they're just the beginning. The world of AI integration is moving so fast, and now we have a whole toolbox of more specialized patterns for very specific jobs. We're going to quickly cover 4 of these key specializations. We'll see how something called RAG lets an AI read all your private documents, how direct DB access lets it query your databases, how a new standard called MCP is trying to be a universal adapter for tools, and finally, how workflow orchestration can handle those really complex, mission-critical jobs. Let's start with RAG, which stands for Retrieval-Augmented Generation. This pattern is absolutely essential when you want an AI to answer questions using your private documents. Think of a huge internal wiki or knowledge base. What it does is it converts your documents into a special format that a vector database can search by meaning, not just keywords. This lets the AI look up the most relevant chunks of text before it tries to answer your question. A huge pro tip here is to force the AI to cite its sources, which makes sure its answers are actually grounded in your real documents. Then you've got DirectDB access, which is super powerful, but you've got to be careful. Here, you're actually allowing the AI to write its own database commands, SQL queries, to pull information right from the source. It's awesome for letting a business user ask something like, how many sales did we have last quarter in Europe in just plain English? But the absolute #1 rule here is to build in serious security, like only allowing read-only access so there's no way it can accidentally change or delete data.
Now this one is really looking to the future. MCP is an emerging standard that wants to be like a universal adapter for AI tools. So instead of having to custom wire every single API for every new model, you could just expose them through MCP, and then any compatible AI could automatically discover and use them. This is all about creating an open, plug-and-play ecosystem. Honestly, the best way to think of it is like USB for AI agents.
And finally, we have workflow orchestration. This is for when a task is really long, really complex, and it absolutely cannot fail. Think about processing an insurance claim or a multi-level refund approval. Now, an agent could try to handle this, but a workflow engine provides something crucial: reliability. The LLM might suggest the steps, but a robust system is what actually executes them, handling errors, retries, and, most importantly, integrating human approval steps for those critical decisions.
Okay, so we have all of these incredibly powerful tools. The big question is, how do we use them without causing total chaos? Because regardless of which pattern you choose, there's some non-negotiable rules of the road for building these things safely and responsibly.
This right here is the foundational rule. It should be the very first instruction in the AI system prompt: stay grounded. Only use the tools and data you are given. If information is missing, ask for it. Do not, under any circumstances, invent facts. This single directive is your first and your best defense against errors and hallucinations. And beyond that, you need layers of defense. You have to validate everything the AI wants to do before it actually changes any important data. You've got to keep an eye on your budget by summarizing big chunks of data before you send them to the model. You need to secure your system against users who might try to trick the AI with clever prompts. And finally, you have to observe everything, log every request, every response, so you can track performance and squash bugs when they pop up. Okay, we have covered a lot of ground. We've seen the two big philosophies, and we've looked at the more specialized tools in the toolbox. So now let's bring it all together and create a really practical guide for choosing the right strategy for whatever you're trying to build. This table is really the key takeaway. It's your cheat sheet for picking the right strategy. And you can see a clear pattern here, right? For a simple, known task like getting a flight status, use this simplest tool, direct integration. But for a critical, multi-step process like handling a refund, you need the rock-solid reliability of a workflow engine with a human in the loop. I'll just leave this up for a moment so you can see how each of these strategies really maps to a specific kind of job and a crucial pro tip to go with it. And that brings us to our final thought. As these agentic systems get better and better, more capable of orchestrating these really complex tasks all on their own, it raises a pretty fascinating question about the future of software development itself. Are we building tools for an AI to use, or are we slowly becoming just one more tool that the AI itself learns to direct? It's definitely something to think about. Thanks for joining me.